Among the various modes of transport, road transport plays a vital role in the economic, social and industrial development of the country. Like arteries in human beings, roads perform a similar function in the transportation of people and goods from one place to another. Before the advent of automobiles, carts and pedestrians were the main road users. Pathways and kacha roads catered to their needs. With the emergence of automobiles and all-round development, the earthen kacha roads could not help in smooth flow of goods and passengers. Hence, the need arose for all-weather and better surface roads so as to provide comfortable and efficient movement of vehicular traffic. If the pavement is not suitably designed and properly constructed, it would lead to uneven surface having poor riding quality, causing discomfort to passengers. In addition, it will increase fuel consumption, wear and tear of vehicle components, resulting in overall increased vehicle operation cost. On the other hand, pavement designed on scientific basis with proper materials and adequate thickness provide smooth riding surface and durability apart from providing comfort to the passengers. In order to understand the concept of flexible pavement design, let us have a look at the component layers of the pavement structure. The different component layers of the flexible pavement comprise sub-base, base course, wearing course, and seal coat constructed over a prepared soil subgrade. When a vehicular load comes on a pavement surface, the load stresses are distributed through different layers and transferred through a wider area of the subgrade. Due to the ability to distribute the load over larger area, the stress gets decreased on the lower layers and is maximum at the point of overlap. Considering this load distribution pattern and the effect of wear and tear caused by traffic, the topmost layer has to be the strongest, requiring high quality material as compared to the underlying layers. Amongst the various methods available for designing flexible pavement, California bearing ratio or CBR is most commonly adopted. The CBR design charts shown here give correlation between CBR value of subgrade soil on horizontal axis and depth of construction on vertical axis for different traffic intensities, that is, number of commercial vehicles per day as given in the charts. Now referring back to the design curves, for particular traffic intensity and known CBR value, which is 8% in this case, The total thickness of pavement comes out to be 20 centimeters. For construction of flexible pavements, the subgrade soil and other materials are tested in the laboratory for evaluating their properties. CBR test is carried out on the subgrade soil to determine the overall depth of construction of pavement. Stone metal is tested for aggregate impact value as per the IS specification. It is also tested for aggregate crushing value to judge its structural adequacy for use in the construction. In the construction of flexible pavement, various operations are involved, such as preparation of subgrade, laying of subbase, laying of base course, and laying of wearing course. The preparation of subgrade involves clearing the site of shrubs, if any, and leveling the ground surface with the help of scrapers or bulldozers. Once the ground is leveled, it is either excavated or its embankment is raised, depending upon whether the road is in filling or in cutting. This stage also involves transporting the soil from the borrow pit and uniformly spreading it in layers with the help of bulldozers or scrapers. Required quantity of water is then added on the selected pavement width, and each layer is compacted by power rollers to bring it to the desired degree of compaction. The subgrade is thus brought to the required grade and camber. The compacted soil subgrade is tested for its moisture content by rapid moisture meter and its value compared with the desired optimum moisture content. On the prepared subgrade, oversized stone metal of desired properties and stipulated grading are spread uniformly, either mechanically or manually. Proper edge protection is given to this layer to provide lateral confinement to the edges before compaction is carried out. The oversized stone metal is then hand packed so that minimum voids are left. As the compaction is carried out, the voids are simultaneously filled with screens and other binding materials. Controlled quantity of water is sprinkled and rolling carried out so as to obtain a compact mass. The rolling is continued till there is no further movement of the aggregates under the wheel of the roller. The layer so obtained is called water-bound macadam, also known as WBM layer. On this constructed WBM layer, a layer of wearing course is provided, which determines the riding quality of the roadway. For this, a mixture of stone chippings of 10 to 12 millimeter size and bitumen is formed in the hot mix plant. This mixture is transported to the site in tippers and dumped into the road paver, which ultimately lays it on the prepared WBM in uniform thickness. However, before placing the premix, the prepared WBM layer is given a tack coat or premix coat so as to enable the proper bonding between the two layers, that is, the WBM and the premix. The premix from the hot mix plant is then uniformly spread over the compacted WBM layer. Once laid, it is then compacted with the road roller and the grade is simultaneously checked with the template. Depressions, if any, are filled with the premix and re-rolled till desired grade is obtained. Lastly, the voids in the premix layer are filled up with a mixture of bitumen and sand prepared in the hot mix plant and is uniformly spread on the compacted premix layer. The road becomes ready for use after compaction. Shoulders of sufficient width and crossfall are constructed along both edges of the pavement with suitable drainage system. The average cost per kilometer for a 7-meter wide dual carriageway is estimated to be between rupees 4 to 5 lakhs depending upon the pavement thickness. The pavement, designed and constructed on scientific basis, will provide comfort to passengers in addition to providing durability and reduced vehicle operation cost.